Hello, ladies and gentlemen. We are going to be doing skill 1.2b, which is over the distance formula. So we kind of are building the distance formula from the Pythagorean theorem to answer a simple question. So in essence, the distance formula answers the question, what is the shortest distance between point A and point B? And the answer, my friend, is a straight line. All right. So what you need to know about the distance formula and where it comes from. So the problem that we ended on last time, we drew kind of a right triangle type of thing going on. So one way that you could solve this is by turning this into a right triangle Pythagorean theorem problem. So let's see, this bottom side is 1, 2, 3, 4, 5, 6, 7. And then this side is 1, 2, 3, 4, 5. So you could actually, option 1 is the Pythagorean theorem. And I'm just going to abbreviate. So in essence, you're breaking it into a right triangle problem. So you got a 7 and a 5 and an x. And then option 2 is what we're going to learn about right now, and that is the distance formula. So just in your notes, you could take a screenshot of this discussion, or you can summarize it on the top of your notes as well. All right, here is what you need to know. You need to know the distance formula. So I'm going to circle what is most important. And you need to know what x1 and y1 and x2 and y2 are. So we're always going to give you 2 points. Now, the distance between 2 points is basically the right triangle, and the hypotenuse is the shortest distance between point A and B. If you are a nerd like me and you want to know where the distance formula is coming from and how it relates to the Pythagorean theorem, this is a really fascinating discussion down here. And I'll keep it pretty simple for you. But the Pythagorean theorem is a squared plus b squared equals c squared. Now, if we want to get the hypotenuse itself, if I take the square root on both sides, and the distance formula just has x direction and y direction squared. All right. So what you need to do when you are doing a distance formula problem, and what you will see me do, you will be provided by me or Delta Math 2 points, always. And you'll need to label each point x1, y1, and x2, y2. Once when you know that, all what you need to do is write down a distance formula and substitute those things into the distance formula. And then once when you have that, apply PEMDAS inside the radical so that you get a whole number. And then you can simplify the radical as you see fit, or change it to decimal depending on what they ask. All right, example 1. This is a typical Delta Math problem here. I'm going to write the distance formula on the top. Thou shalt always write down the distance formula, and you will have a correct setup when you do that, provided that you label the points. So I'm just going to put those in. So my x2 is -5. So I have -5 minus a -7. Always be careful with what's inside of a parentheses and the change of signs. That's a common place where people do make mistakes, but if you are staying true to PEMDAS, you will be in good shape. And then my y2 is 7, and my y1 is 1. So I got -5 plus 7. So that's going to be a 2 squared. I'm just going to kind of put a little note there that that's what we did. Yeah, -5 plus 7. And then 7 minus 1 is 6 squared. So that's going to get me to square root of 4 plus 36, which is square root of 40. And they want simplest radical form. Now, if you stopped at square root of 40, you would get most of the points, but not all the points on the test. This tells me that you do know the distance formula through and through, but you need to get it in the correct form. So I'm just going to write my perfect squares. And I'll just write up until 36. I do see that 4 goes into 40 10 times. So I'm going to do square root of 4 times square root of 10. So I'm going to get 2 square root of 10. And that is my final answer. Sometimes they'll give you, like on the next example, a decimal form one. This is find the distance between the 2 points, rounding to the nearest tenth. One thing that does not change is the distance formula. If you write down the distance formula in your notebook each time you do one of these problems, you will eventually memorize the distance formula in no time. So I've got x1, y1, x2, y2. All right, substitute x2 in. So I got a 1 minus a -7 squared plus -3 minus a -7 squared. Remember, we got to change inside. So I got 1 plus 7 squared. So I'm just going to kind of do this since there's so many negative signs. -3 minus a -7. So that's -3 plus 7 squared. Don't square root until you get to that whole number inside of a radical. So I got 8 squared plus 4 squared. So that's going to be 64 plus 16. So that's the square root of 80. And nearest tenth is 1 decimal place. So I could just go to my handy dandy scientific calculator or Delta Math calculator. And I can actually see what the square root of 80 is. It's 8.94. So that's 8.9. And that goes as your final answer. And that, my friend, is the distance formula. So thank you very much for tuning in.